Hi students, welcome back. So in the last class we discussed about the Biot-Savart's law first, and then in the second lecture we actually discussed about what would be the magnetic field, due to a current carrying wire at a point P in the vicinity. Okay, and we did some derivations. Now a few questions which will help you develop this understanding, and you will find a lot of questions in various books, but again let me cover a few things. Like, now suppose there is a wire like this, it's a straight wire, and you have a point, let's say P here, and you have to find what would be the magnetic field here at this point, because of this current carrying conductor. This is nothing but current carrying conductor. Okay, now we will directly go to the formula. You know it, right? Formula is B is equal to mu naught by 4 pi, right? This is the current, so this formula is I by A, and this is sine theta 1 plus sine theta 2. Now in this case, if you relate it with the diagram which we have drawn earlier, like it was something like this, right? And this was the perpendicular distance, and this was a dl which we have taken, so it was like this. So if you remember, this was theta 1, and this whole was theta 2, and this was theta, correct? So if you compare this, if it is in a straight line, then theta 1 is equal to theta 2 is equal to 0. So it's nothing but mu naught 4 pi I by A into 0 plus 0, which is equal to 0. Now this basically means that the magnetic field at any point which is collinear to the wire would always remain as 0, and this you would be utilizing very often while you solve numericals. Okay. Okay, let me move on to another point which says that this is an infinity wire. It's this wire is up to infinity on both the sides, and we want to find magnetic field at point P. Now again going back to the formula, if you see that when I say infinity, means it will be very far, and it would be both lines would be parallel. So you can say that this angle, the one which we are talking, will be 90, and this would be 90. Now again going back to the formula, mu naught by 4 pi I by A, B is equal to this, is and sine theta 1 plus sine theta 2. This is mu naught 4 pi I into A into 1 plus 1, which is 2. So it is mu naught 4 pi 2I by A. If I cancel this, because 2 and 4 get cancelled. Okay, so you have to remember this, because it's not feasible to derive it every time. That whenever it is the wire is infinity wire, in the sense like it extends to infinity, then the magnetic field because of that wire at any point would be mu naught by pi 2I by A. Okay, now similarly you can work out, if someone says the wire is something like this. If I wanted to if I wanted to change it, I can change it like this. If the wire is a semi-infinity wire, now if it is a semi-infinity wire, very simple, you can directly say that this is 90, one side it is 90 and one side it is 0. So it finally extends to, if it is a semi-infinity wire, sine, it becomes whatever it is. It's a normal calculation. So it will become what, mu naught 4 pi I by a, and then this becomes 1 plus 0, and this is mu naught 4 pi I by a in case of, you know, semi-infinity wire. Okay, very good. And okay, let me cover one more very good questions and question which will help you understanding this topic more. Okay, so there is a wire, let's say there is a wire like this, and there is a point somewhere here. Let's say it's here. Now, the details which they have given is the wire is carrying conductor like, I, and what would be the magnetic field at point P? So this angle, this angle they have given as this is 30 degree, this is 30 degree, and of course, so this is the question that, in such a scenario, what would be the what would be the magnetic field at this point P? Now students will get stuck because it is not straightforward, right? So again, you have to complete this this figure and make it something like this. Now this is 90, so this would be 60 degree. Okay, now go back to the formula and relate it with the figure. Now let me draw the figure, the one which we had, which we through which we derived, and the figure is something like this. Theta 1, and this is theta 2, and this was the DL we have spoken about. So just compare it with this. In this case, you have to remember the formula is mu naught by 4 pi I by a, and this is sine theta 1 plus sine theta 2. Okay, now two things. Number one, this, okay, before I come to the to angle, remember A is the distance, this distance, perpendicular distance, and I have emphasized in my lectures that A is a perpendicular. So the first thing you have to do is this is D, so this would be D cos 30. So D cos 30 would be the perpendicular distance, and this will go, so this would be A, so A would be D cos 30. Okay, now coming on to angles, and if I compare this with angle, let me start with, remember I always told you the base would be this. You have to calculate the angle from this horizontal line, So if you see that side, it goes what, let me come one by one. So one is this. So if I talk about this, it goes how much? It goes how much? Think, pause your screen a bit and think over it. Okay, I'm letting you know the answer. So theta 1, theta 2, so this is 60, and this would be 360 minus 30. Because this line, basically, I will look from here. If you see here, see this line, basically I am looking this way. So you have to look at that way. So just take, you have to, so it will be what? It would be 360 minus 30 degree. So it will come till here. Okay, so that is about theta 1. Now if I talk about, the other is 60 degree angle. As I said, I have to take it from here, so 60 degrees. So if you see from here, it is 60 degree. Correct? Okay. So, again, now if I put it this way, then this question condenses to mu naught by 4 pi I by A and sine 60 plus sine 330. Okay, very good. And again, now you can solve this question. Well, I think, yeah, yes, you have to note one thing, and there is something wrong with the figure. Basically, this angle, is this whole angle is 60. This whole angle is 60. And hence, this is the answer. Okay, so similarly, we can cover a few more questions and we can get going. We can start with this. The next would be, magnetic field due to a circular current carrying loop in, in arc.